So, today we are going to discuss the properties of the sampling distribution of sample mean. So, the first property is, so this is the property. The mean of the sampling distribution of mean is denoted by mu x bar or x double bar, and it is given by mu x bar is equal to mu. ठीक है, this for both the cases, both for sampling with and without replacement. चाहे आप लोगों ने सैम्पलिंग विद रिप्लेसमेंट की है, चाहे विदाउट रिप्लेसमेंट की है. सो इन बोथ दिस केसेस, मतलब जितने आपके पास मीन आ गए हैं, फॉर एग्जांपल आपके पास 10 मीन है, अगर आप उन मीनों का एवरेज लें, उन सारे मीन्स को टोटल कर दें और उसको नंबर ऑफ मीन्स पे डिवाइड कर लें, तो इसे पॉपुलेशन मीन आना चाहिए. ठीक है, इसको अनबायसनेस प्रॉपर्टी भी कहा जाता है. कौन सा प्रॉपर्टी? अनबायसनेस प्रॉपर्टी. आप इसको वेरीफाई भी कर सकते हैं. अगर आप इसको वेरीफाई करना चाहें तो लेफ्ट हैंड साइड इसका बराबर होता है समेशन एक्स बार इंटू एफ ऑफ एक्स बार, एंड इसका राइट हैंड साइड बराबर होता है समेशन एक्स आई डिवाइड बाय एन. तो ये है इसकी वेरिफिकेशन और इसको हम वेरीफाई कर लेंगे. To verify this, let us take an example, and for example, the example is, ये हमारे पास है example. ठीक है, a population consists n is equal to 5, in population size is equal to 5, and these 5 observations are 2, 4, 6, 8, and 10. The question is, draw all possible samples of size n is equal to 2 with replacement, and construct sampling distribution of sample mean, and verify that mu x bar is equal to mu. This is also the first property of the sampling distribution of sample mean. So, let us proceed. कल हमने डिस्कस किया था कि हम किस तरह sampling distribution of sample mean बना सकते हैं. तो हमारे पास possible samples कितने आएंगे? First of all, you have to decide about possible samples, and possible samples हमारे पास आएंगे. Since the method is with replacement, so it will be n to the power n. N is equal to 5 and small n is equal to 2. This is equal to 5 into 5, and this is equal to 25. So, we will have 25 possible samples. Now, according to the first step, take this 25 and divide by the first 5, this one. So, you will get 5. So, you have to write each and every observation 5 times, and then we will have to follow the second step, which is choose this 5 and divide it by the second 5, and this time this is equal to 1. So, the procedure is we have to write each and every observation 5 times. In the second round, we have to write each and every observation only once. So, how can we do this? Let us do it practically. So, writing each and every observation 5 times, for example, 5 times 2, 4, 6, 8, and 10. So, we are done with the first step. We have written each and every value 5 times. In the second round, we have to write each and every value only once. So, 2, 4, 6, 8, and 10. Similarly, 2, 4, 6, 8, 10. You have to complete this cycle. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, and 10. So, these are the samples, and now we have to calculate arithmetic mean from these samples x bar, from each and every sample. For example, the average of these two is 2, the average of these two value is 3. Similarly, 4, 5 and 6, 3, 4, 5, 6 and 7, and this is 4, 5, 6, 7, 8, and this is 5, 6, 7, 8, 9 and 6, 7, 8, 9, 10. So, we have calculated mean from each and every sample. Now, the rest of the procedure is you have to report each and every sample mean only once and go for tally bar sheet. The minimum arithmetic mean is 2. It starts from 2 and end by 10. So, 2 through 10, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now, go for tally bar sheet, tally 2, 3, 4, 5, 2, 3, 4, 5, 6, 3, 4, 6, 3, 4, 5, 6, 7, 5, 6, 7 and then 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9 and 6, 7, 6, 7, 8, 9, 10, 8, 9 and 10. So, we are done with this. अच्छा, ये देख लें, अगर 4 कंप्लीट हो जाए तो 5 इसके ऊपर क्रॉस करते हैं ताकि ये पैक हो जाए और इसके गिनने में आसानी हो. तो दिस इज द वे. अब देख लें, वी हैव टू कैलकुलेट सो मेनी थिंग्स फ्रॉम इट. Generate frequency from the tally, just count it 1, 2, 3, 4, 5, 4, 3, 2 and 1. If you count it, it must equal to the number of possible samples, which is equal to 25, right. The next step is calculate probability from it. 2 appears only 1 out of 25 sample means. So, its probability is 1 over 25. Similarly, 3 appears 2 times out of 25. So, 2 over 25. In the same way, you can complete it. And these are the respective probabilities. And this is nothing else. This is the sampling distribution of sample mean. And now, we have to go for verification of the property, and if you add it up, this is equal to 25 over 25 and this is equal to 1, and this one is nothing else. This is the total probability of the sampling distribution of sample mean. Now, according to the property, we need few things. For example, the property is mu x bar, this is equal to mu. So, we need the left hand side. The left hand side, this is the right hand side. For the left hand side, we need summation x bar into f of x bar. Now, we do have these two columns. X bar column is given by this first column and f of x bar column is this. So, we have to multiply these two columns. So, x bar into f of x bar, multiplying these two columns. For example, 2 into 1, 2, 2 over 25, 3 into 2, this is equal to 6 over 25. Denominator remains constant. 4 into 3, 12 over 25. In the same way, you can complete this column. So completed. अब आप इसको ऐड कर ले, you have to sum it up so as to get the left hand side. The denominator will be 25, and if you add the numerator, you will get 150 over 125. So, this is equal to 150 over 25, or this is equal to 6. So, the left hand side is equal to how much? This is equal to 6. Now, we have to calculate the right hand side, and in the right hand side we know that x I is equal to the population data, which is 2, 4, 6, 8 and 10. If you add these values up, this is equal to 30. This 30 is what? This is summation x I, and mu, you know, mu is equal to summation x I divided by 5, n, capital N, and summation x I is equal to 30 and n is equal to 5. So, this is equal to summation x I divided by n, or 30 divided by 5, or this is also equal to 6. So, the left hand side is exactly equal to the right hand side, and this is the verification of the first property of the sampling distribution of sample mean.